Hello, everybody. Today, the NanoGames team will be presenting our augmented reality video game research. Our team consists of the programming side and the artist side. For the programmer side, we have me, Janiel Diaz, Michael Delgado, Rosaidi Millán, Jadel Sullivan, and Natalia Roldan. And for the artist side, we have Roxangeli Cintron, Edwin Vicenti, Adrian Cruz, Nathaniel Gonzalez, and Gabriel Luque.
The NanoGame Research project aims to deploy an augmented reality AR mobile application to address the motivation of Hispanic middle and high school students to pursue STEM careers by presenting the creation of an AR game that introduces the concept of nanotechnology and the performing tests to assess its motivational effectiveness. The proposed application is a modular mobile AR system that will contain several game-fit nano experiments. It will be deployed by undergraduate students from the University of Puerto Rico at Maya West with advice from Dr. Nadia Santiago and domain expert from the field of nanotechnology.
The problem we're solving is that it is difficult to teach nanotechnology concepts to middle and high school students, because instructions require specialist equipment and environments, as well as advanced mathematical concepts which aren't available to the regular student. The student needs a way to conceptualize objects and processes that aren't visible, but that are real. Augmented reality allows access to the nano world through interactive visualization of the concepts, making learning difficult concepts fun instead of scary. AR allows us to see nanotechnology in its context, reality.
Our team has been developing an immersive AR experience comprised of 3 minigames with the purpose of promoting intrinsic motivation for middle school and high school students with fun and innovative methods. This is all for the purpose of raising their interest to pursue STEAM-related careers.
For the project methodology, we divided it into three parts: design, implementation, and testing. For the design phase, we focused on improving upon the designs established last semester, complemented by research and meetings with experts in nanotechnology and education. For the implementation phase, we began working on the first of three minigames with an agile scrum workflow. Once we have a playable build that has been verified by domain experts, for the testing phase, we will have middle and high school students play the game and survey the impact it had on their motivation and engagement towards nanotechnology and STEM.
To accomplish the project's primary goal of developing an augmented reality game, the team selected Unity 3D and AR Foundation. The Unity 3D game engine will be used to develop the game using the C# programming language, and AR Foundation will provide the framework to build it using the AR technology.
The game design is divided in four parts: the hardware and three different minigames. The hardware is the main menu of the game. It's the first thing you see when you enter the game. There you can find the accessory, extra, and the setting. Also, you find the three minigames. The first minigame, the player has to find the UV bits inside the library made of a forest fortress. The challenge will be to escape the labyrinth by finding all the required UV bits in a limited time.
In minigame number 2, the player is set to play the role of a nanoparticle doctor who is required to fix anomalies in each organism's nanobody. Once inside the organism, the player must locate damaged DNA strands that require to be fixed immediately. Once the player locates the damaged DNA strands, he will be able to analyze and verify what is missing of them in order to be able to fix them. In minigame number 3, the player must successfully train a nanotech filter in order to let cells that are harmless to the human body pass through, but stop cancerous cells that are passing by. Through a monitor, the player will be able to see the nanotech filter and a wave of cells coming by. As the cancerous cells gets closer to the filter, the player must activate it in order to destroy them.
I will be presenting the project metrics or goals. In the short term, we expect to complete the minimum viable product, which we have defined as the hub world and one of the 3 levels in the game. Additionally, we want to make sure that the team grows professionally and personally by involving each team member in every part of the project. In the long term, we expect to release the AR application in both iOS and Android operating systems. This will increase the number of players that download the game. Finally, we want to measure the educational impact of the application. Are students really learning the concepts we are trying to teach them throughout the game? Are students motivated to learn or eventually pursue careers involving these topics? These are the questions we look to answer.
The audiences for this project are middle and high school students from public schools. This video game mode covers two industries, education and entertainment. On education serves as a visual tool to teach nanotechnology topics and motivate to follow STEAM careers. And on entertainment, with its video game mode, serves as fun and distraction. This combination creates a positive growth on the success of this app because it covers a broader market.
The implementation results are displayed in this slide through images. To the left of the screen, a first-person view of the game running on a mobile device is shown. AR objects including the maze and bees are generated around the player. An initial UI is presented which allows player movement and modifying the maze for testing purposes. The maze layout is chosen at random, and in the middle of the screen you can see some alternatives. At the right of the screen are the sky and first-person views from Unity. Hundreds of bees are instantiated in random positions to demonstrate the depth of the maze.
On the other side of the implementation phase, the art team built 3D models of assets to be used in the level 1. Some assets are rocks, a microscope, a molecule structure of a UV bead, a background scene along the siege of the game, a signboard, and different stages of a bead from a superficial view. These assets were made with the software Blender.
For the next steps, we plan on creating playable builds of the game and iterating based on input from experts in nanotechnology and psychology of education. Here we have the team's contact information, and thank you for your time.